Hello everybody, today we are going to do 5.2 systems of linear equations in 3 variables. So 3 equations, 3 unknowns. Yes, or the last video, 5.1, was 2 equations, 2 unknowns. So these take a little bit longer, but you just have to be organized in your work and they're not so bad. I'm going to start with checkpoint 1, which is basically just showing you how to check your answer again, same way 5.1 started. So we're going to show that the answer is a solution. Show that the ordered triple is a solution. Alright, so we're given the system of equations. Again, I said it's going to be 3 equations, 3 unknowns. We have x minus 2y plus 3z equals 22. And we have 2x minus 3y minus z equals 5. And 3x plus y minus 5z equals negative 32. And then the point that we're given is -1, -4, and 5. This is called an ordered triple. Your ordered triples go x, y, and z. It's 3 dimensions is what's happening, because xy plane is actually just like a flat piece of a 3-dimensional plane, which is x, y, and d, which shows depth. So -1 is our x, -4 is our y, and 5 is our z. So I'm going to start by plugging it into the first equation and making sure it works. This is the other one. In 5.1 I said, does it work? This one's saying it works, show that it does. Okay, this is the answer we got, show that we did it right. Okay, so -1 plus 8 plus 15. So that's 7 plus 15. Does it equal 22? Yes, it does. So there it works in the first equation. So next I would go to the second equation and test our ordered triple in that one. So 2x minus 3y minus z equals 5. So 2 times -1 minus 3 times -4 minus 5, does it equal 5? So -2 plus 12 minus 5. That's 10 minus 5. Does it equal 5? Yep, it sure does. And then you just have one more to do. So in the third equation, 3x plus y minus 5z equals -32. We have 3 times -1 plus -4 minus 5 times 5. Does it equal -32? That's -3 minus 4 minus 25. -7 minus 25. Yep, that equals -32. We're good to go on checkpoint 1. It works in all 3. We're good. Alright, so that's actually just how to check your answer. The checkpoints... Okay, I'm going to do checkpoint 2, checkpoint 3 basically, but I'm also going to do example 2 and example 3. Reason being that checkpoints kind of do special things, which anytime like different things happen, my biggest advice is just roll with it. And remember, your goal is just to solve for each variable. Right, so this is actually example 2. We're solving the system. Alright, so now we've got 3 of them to deal with. We have 5x minus 2y minus 4z equals 3, and 3x plus 3y plus 2z equals -3, and -2x plus 5y plus 3z equals 3. So basically what you need to do is get rid of the same variable twice. So you want to pick a variable that you think would be not too bad to get rid of 2 times. So look at the x's, I have 5, 3, and -2. Looking at the y's, we have -2, 3, and 5. Looking at the z's, we have -4, 2, and 3. Honestly, none of them are super fantastic easy. So I'm just going to kind of I'm going to pick the z's. So I'm going to use these two first. And I'm going to eliminate the z's from those 2 equations. The biggest issue people have is not that they can't do the math. The math honestly isn't that bad. It's they can't keep their stuff organized. So just keep your work organized and it won't be bad. So we have a -4 and a 2. I'm going to make this one have a 4 in front of its z. So I'm going to multiply by 2. And then I'll make the z's eliminate. So the first equation will stay the same. And the second equation becomes 6x plus 6y plus 4z equals -6. Z's cancel. 5 plus 6, that's 11x. -2 and 6, that's plus 4y. 3 and -6 is -3. Alright, so now we have an x, a y, and a number. Fantastic. Now I'm going to do 2 others. I always hate dealing with negatives, so if I can avoid it, I do. So that's why I'm picking these 2 now, because you have a -4 and a +3. So that means you don't have to deal with it, because you already have opposite signs. Remember, we have to get rid of z, since we got rid of z the first time. So now I'm using the first and the third equation. But I am going to have to multiply both equations of this one. So 3 and 4 both go into 12. So I'm going to multiply this first equation by 3 and the second equation by 4. 15x minus 6y minus 12z equals 9. Second equation, we have -8x plus 20y plus 12z equals 12. So now we add them together. 15 minus 8, that's 7x. -6 and 20, that's plus 14y. These will cancel. Equals 21. Here's another trick too. 7, 14, and 21 are all divisible by 3. They're all divisible by 7. So this might make that problem easier to go through and divide the whole thing by 7. Because then you're just going to kind of have easier numbers to work with. Because what we're going to do next is pull these 2 to get together and get rid of a new variable. So x plus 2y equals 3. Sometimes it makes it easier, sometimes it doesn't. So this is how I always set up my work. I do the 2 this way, so these 2, and then I pull them together and I'm going to work down the middle. That just keeps myself organized. But you do what works for you. Okay, so now I'm going to pull these 2 together. 11x plus 4y equals -3 from here. And x plus 2y equals 3 from here. And we need to eliminate a variable. I'm going to go ahead, we're going to have to deal with negatives here because I'm going to go ahead and deal with the y's. You got a 4 and a 2. If I just multiply this one by -2, then we'll have a -4. You could have also multiplied by -11 and got rid of the x's. Up to you, whichever one you want to get rid of. But this is going to narrow us down to just one variable. Because now the y's will cancel. You have 9x equals -9. Divide by 9, so you get x is -1. Alright, so now we have one answer. Now you just work your way back up till you find another answer. So I can plug this in. You don't want to go all the way back to the top because those have x, y's, and z's. You want something with just 2 variables. So pick one of these 2. I'm going to pick that one. It's just kind of an easier equation. X plus 2y equals 3. Plug in the -1. So negative 1 plus 2y equals 3. Add the 1, 2y is 4, which means that y is 2. Now you gotta grab something with a z in it. So now go all the way back to the original and just pick something with a z. I'm gonna pick the middle one because it's got a 2z. It honestly doesn't matter. You can pick whichever one you want. So 3x plus 3y plus 2z equals negative 3. But now we know the value of x, it's negative 1. And we know the value of y, it's 2. So negative 3 plus 6 plus 2z equals negative 3. 3 plus 2z equals negative 3. So 2z is negative 6 when you subtract the 3. Divide by 2 and you get z is negative 3. So our final answer, putting it in x, y, z, is negative 1 to negative 3. Okay, these take a lot of work, but they're not bad. Like, just be organized about it. Get rid of one variable, get rid of the second variable, then start plugging your way back into the top. All right, checkpoint 2. I don't remember what happens. I feel like something. Well, no. You know what? It's checkpoint 3. Has something special happen. We'll see. If you're good to go, you can always fast forward. That's the nice part about doing these videos, is if you're like, all right, I get it. So if you get this, fast forward and go to checkpoint 3, which will have holes in it. So this one doesn't. But if you need another one to look through, here you go. Or you could do it ahead of me and then check your answer. There is perks to having a video instead of live. All right, so 3 equations. And 2x minus 3y plus 2z equals negative 16. These things are the whole reason I cross my z's. All right, so again, we're getting rid of one variable twice. This one's set up nicely. It's got a negative z and a z. You don't have to get rid of z first, but this one was pretty convenient. All right, so I'm using the first 2 equations first. And I don't have to do anything to set it up because these two have the z and the negative z, so they cancel. So you end up with 4x plus 6y equals 28. I do notice they're all divisible by 2. I don't know if it'll help or not, but I feel like a simpler answer is always just kind of nice. Ah, dang it. Okay, so 2x plus 3y equals 14. All right, there's equation number 1. Now I'm going to do the negative with the positive. This will be my second set of equations. You can pick whatever 2 you want, but if you got rid of z here, you have to get rid of z over here as well. So the first equation and the third equation, getting rid of z. So all I need to do is multiply this first equation by 2. So you have 2x plus 8y minus 2z equals 40, and 2x minus 3y plus 2z equals negative 16. So you have 4x, a positive 5y, z's are gone, equals 24. All right, so 2 equations, 2 unknowns now. Now we can bring those 2 together. And actually, I see a 4x and a 4x. We're probably better off not dividing by 2. So I'm actually going to use I don't know if that'll be confusing or not. No matter what, I'm going to multiply this equation by a number. So, but I'm actually going to use this one. 4x plus 6y equals 28. And from here, 4x plus 5y equals 24. Alright, so one of those has to be multiplied by a -1. So 4x plus 6y is 28. Negative 4x minus 5y equals -24. 6 minus 5, that's 1y equals 4. Okay, so we got our y. Oh, I'm looking at the wrong answer. Okay. Alright, so y is 4. Now I need to plug that in to an equation that just has x and y. So I'm going to plug it in here. So 2x plus 3 times 4 equals 14. 2x plus 12 equals 14. Subtract the 12, so 2x is 2. Divide by 2, so x equals 1. Alright, now we got x and we've got y. So now we need to go all the way back to the beginning and pick an equation with z in it. I'm going to pick the one that just has 1z, so I'm going to go with the middle equation. 3x plus 2y plus z equals 8. Plug in 3 times 1 plus 2 times 4 plus z equals 8. So 3 plus 8 plus z equals 8. 11 plus z equals 8. Z equals, -3. Okay, so z is -3 when we subtract the 11. So our final answer will be 1, 4, -3. Okay, that is checkpoint 2. All right, now checkpoint 3 and example 3, these have holes in them, so it already has variables missing. And it's kind of a tricky thing to teach because, like, every situation is going to be different. So you have to kind of evaluate what you have, what's already gone, that kind of a thing. And checkpoint 3 has, like, it's kind of special, so that's what I need to do. I definitely need to do example 3 on this one. But I will also do checkpoint 3. All right, for example 3, we have the system of x and then plus z equals 8. It's just typically written with a space there, so I'm going with it. And then we have x plus y plus 2z equals 17. And then x plus 2y plus z equals 16. Alright, so the thing that happened here is the first one is already missing its y. So you want to pick another set and get rid of y. Like, you kind of have to. You're forced into it. So I'm going to put these two together first, and then I don't have to do another one because we'll just use that equation. So I'm going to put x plus y plus 2z equals 17 together with x plus 2y plus z equals 16. Alright, one of these is going to have to, what am I getting rid of? Y, sorry. So I'm going to multiply this one by -2. So we have -2x minus 2y minus 4z equals -34. And then x plus 2y plus z equals 16. -2x plus x, that's -1x. Those cancel. -4z and z, that's -3z equals, I don't totally trust my mental math on this one. 4 plus plus 16, negative 18. Okay, so we have that equation, and then we have the first equation. So I'm going to put this is like the down the middle part. We're just automatically there because we have two equations, two unknowns. And the even better part on this one, our x's are ready to be canceled out when we add together. So negative 3z and z is negative 2z equals negative 10. Divide by negative 2, so z ends up equaling 5. There's one answer. Now I need to find an equation with a z and one other variable. I'm going to use the x plus z is 8. That's a nice and simple equation. Plug 5 in for z. So x plus 5 is 8. Subtract the 5 and you get x is 3. Now we need an equation with x, y, and z. Or just a y and something else. It doesn't have to have all of them in it. But I'm going to go back to this one from the middle up here. Plug in what we know. We know x is 3. And we know that z is 5. So 3 plus y plus 10 is 17. 3 plus 10 is 13 equals 17. So y equals 4. Alright, so our answer will be 3, 4, 5. I like the ones with holes better. You just get to kind of do what works. I can just get through it. So the other ones take forever. Okay, now checkpoint 3 has some unusual circumstances in it. So it kind of teaches you to roll with the flow. We're solving again. Alright, so checkpoint 3, we have 2y minus z equals 7. Then we have x plus 2y plus z equals 17. And then 2x minus 3y plus 2z equals negative 1. Alright, so this one in the beginning is missing an x. So we need to put the second two together and get rid of an x, just so they can both have y and z. So putting x plus 2y, plus z equals 17 together with 2x minus 3y plus 2z equals negative 1. So like I said, we need to get rid of the x's. So I'm going to multiply this first equation by negative 2. You end up with negative 2x minus 4y minus 2z equals negative 34. Second equation stays the same. When we add them together, the x's and the z's eliminate. So you have negative 7y equaling negative 35, which tells us that y is 5. And you go straight to having an answer. That will definitely not always happen, but it's nice when it does. Alright, now I need an equation with a y and one other variable, which I do have in the beginning. We have 2y minus z equals 7. So I can just plug that in for my y. Excuse me. So 10 minus z equals 7. Subtract 7 minus 10, you get negative 3. So if negative z is negative 3, positive z is positive 3. Now I have another answer. Now I just need to find an equation that has x in it and then solve for the x. I'm just going to go with that middle equation. The x plus 2y plus z equals 17. So x plus 2 times 5 plus 3 equals 17. X plus 10 plus 3. So x plus 13. Subtract the 13 and x is 4. And there's all the pieces parts to your answer. So our answer is 4, 5, 3. All right, that is 5.2. I hope you enjoy it. I kind of like that one, but I like very algebra-ish stuff. Have a great day and be safe.